much for the kind introduction, Anna. Hello, everyone. I promise I will try to keep this somewhat entertaining despite the technical topic. Um, I certainly am looking forward to my coffee, and I'm sure so will all of you as well. So diving right into it, I'm going to be setting the stage today, and then Mike here will actually tell you all about the technical details. So in our world, we focus a lot on ML operations, which is a ever-evolving environment with lots of different roles, lots of different ways to getting into this space. We're still trying to square exactly what ML operations means for us, and really looking at this space, we find it rapidly evolving year over year. So when I think about ML operations at a place like Capital One, we have hundreds of different use cases and scenarios that we will be dealing with, but to introduce you to a typical one that you'll find at a place like Capital One would be transaction fraud. So if you think about how you need to run inference on to make a decision whether a credit card transaction might be fraudulent, yes or no, you need to do this within milliseconds. You need to be able to provide that inference back to the point of sale so that you have a quick approve decline decision on a transaction, and you need to do that at scale, and you need to do this highly resilient. That's the line of business that we're in. That's what we're going to be sharing with you today in terms of like the industry trends that we see in this space and some of the opportunities that we see there specifically. So there's a lot that goes into that. There's this paper that I love to refer to in terms of all the different components that go into creating these systems in a resilient and scalable way. So you need to first train a model to predict the approved decline decision. You need to have secure data flows. The system needs to be able to scale, and you should really not have any downtime for any of this, right? Like every transaction counts. And so we will be focusing today on the serving infrastructure here in particular, but really a lot of the discussion ends up being about this space, but there is so much more that goes into actually getting it all done. And today we'll be looking at this part, the serving infrastructure. So operations and the success in this space really I like to think about it in terms of this Venn diagram. There's disciplines there, both in terms of the model training and the model serving capabilities that you need to build. They're complementary to each other, but there's also a fair amount of overlap that you need to navigate. So in doing this at enterprise scale, comes with its own unique set of challenges. So if you think about this in in the financial industry, for a company like Capital One, you're dealing with hundreds of these use cases. You have to figure out the requirements around controls and compliance, as well as multi-tenancy, to be able to do this not just for one use case, but for hundreds of them. And so, I need to point this way. So there's a number of inherent challenges in this. There's a lot of different things that you need to get right to be able to build these types of capabilities. You want to invest in things like SDKs and libraries. You want to figure out that you have a system of record for the artifacts that you're pushing into production. You'll be able to track your models and be able to say this model that's running in production was actually trained over here, and this is what it's supposed to do. You want to be able to kind of create a framework within the enterprise that allows for reuse of your capabilities, and you need to have enterprise support for all of that, right? The final one that we're going to be focusing on today is how do I create a unified stack that is efficient to run, that I have a relatively low run the engine cost on, and that provides all the capabilities that I need to make that approved decline decision, as well as a couple hundred other use cases. And so that's where we're going to be talking about a specific technology that we use, and over to Mike.
So one of the most common platforms or frameworks that is used in the industry is Kubernetes. So Raise your hand if you know what Kubernetes is. Okay. Of you, who has trained and or deployed a model via Kubernetes? A decidedly even lower number. Okay. So there were hands that didn't go up for either question, so I'll do a brief explanation as to what Kubernetes is. Do not make any decisions based off of this because it's, you know, the Spark Notes version. Kubernetes is you have a pool of instances, EC2s, Raspberry Pis, what have you, and to the cluster that is a pool of resources. Onto that pool of resources, you ask Kubernetes to deploy groups of containers known as pods. And then, you know, Kubernetes has a lot of cool orchestration things like if one of those containers goes down, it will automatically reschedule a new one, replace it, et cetera, et cetera. So Seldon here is is a really mature product in the industry that we use, and it is based on Kubernetes. It is open source. It is you know, a way of serving models and constructing a directed acyclic DAG. So input transformers go to two separate models, go to output transformers and things like that. It does a lot of cool traffic routing things like A/B testing, which we learned about earlier, multi-arm bandits, traffic mirroring, a lot of that is cool stuff. And it overall simplifies the job of deploying a model in a real-time environment. So let's talk about what V1 of Seldon can do. So this is a little bit of an advanced topic in Kubernetes. So Kubernetes has something called custom resource definitions, which is an extensible set of APIs to customize the cluster. So for example, if you have a set of deployments and services that all connect together, you say, I want to define it in a slightly different way, but still, you know, create those resources underneath. That's where a custom resource definition comes in. And so this is what Seldon's custom resource definition looks like. You define, go back. You define, you know, your graph, your different, you know, containers, what the type of model is, and then Seldon has provided what's called an operator, which is just a microservice that runs in the cluster and listens for those custom resource definitions and converts it into actual like running resources. So in this example, we have predictors that defines like an input transformer combiner and a model over here, or two models. Over here, we see that in this slightly different graphical form of, you know, the input transformer, the two models, and then the combiner of both of those. So models as a service at Capital One is built on top of Seldon, and it abstracts Seldon in a way that simplifies things for you as a user. And, you know, in terms of MLOps in the industry versus data science, there's not always a ton of overlap in there. So judging from the number of hands that went up, some of you may know what Kubernetes is, but not everybody knows what Istio is. That's the service mesh that connects all the things together, and, you know, operators and all that stuff. So you leverage MAS to adhere to industry and enterprise requirements, which I call the thou shalts. Thou shalt use trusted golden images. Thou shalt produce metrics. Thou shalt produce logs. Thou shalt register thy model on an API gateway. You know, thou shalt manage your secrets, 99% resilient, be on call 24/7 in case, you know, Vincent wants to, you know, swipe his credit card at Walmart. You know, you don't want the model service to say, I'm not available. So this is a somewhat simplified version of our architecture. We have, like I was talking about earlier, users and clients, the API gateway, our abstraction layer that, you know, makes it simpler to interact with Seldon. And then we have the Seldon deployments behind it that come with all of Seldon's abilities, including the directed acyclic graphs, Istio routing, scaling, etc. So we're looking at where things are going, in particular with Seldon. And Seldon has recently come out with V2 of their what's called Seldon Core offering. It defines new custom resources. So all of that you know, custom resource I showed you on the slide that I started with, they define new ones, which are servers, models, pipelines, and experiments, which stitch together the servers. And then the CRDs the APIs are still technically in alpha, but the V2 offering from Seldon has since gone GA. And this change in the custom resource definitions has a large impact on our control plane and how those abstractions are developed. This is, again, a bit different of a graphical representation. So like I said, we have the models. Servers can run one or more model, and then you stitch together these servers and models with pipelines and experiments. So this shows like V1 had it all in one custom resource definition. V2 splits it out so that you can actually stitch different servers and models into different pipelines and experiments. So that's actually a really interesting way of doing it. Like I said earlier, this is not technically true anymore. When we did the POC, it was in alpha. It, like I said, has gone GA. So one of the most interesting aspects of V2 is what's called multi-model serving. So you have multiple different ML models on one single server or inside of one container. It allows improved resource utilization, particularly in the GPU space. So like if you have an underutilized GPU, this helps solve that by saying, maybe I can share that GPU between 3, 4, or 5 different models on the same container and just dynamically load those into memory as requests come in. Now, there are questions such as some regulatory requirements in the financial sector. Regulators want to know what's going on, and it's not invalid. So we have to say, how do we replicate the quote state of the world when that request came through? So what model was loaded into memory beforehand? What model was loaded after? We also don't have great metrics on what a cache miss latency is. There are some metrics that are provided from Seldon. However, they're with relatively small models. And there are custom libraries that I'm sure many of you use. So how do we fit that into the existing multi-model server pattern? Do I have to build an entire server from scratch? So this down here shows kind of the general process of, okay, I have one server serving many models or many instances of the same model. If I get a request for this red one, it will force ones to be loaded out of memory into disk or into memory from disk. So that obviously has essentially a cold start penalty. So multi-model serving, like I said earlier, can help with resource utilization when it comes to expensive and hard to get resources like GPUs. But it also comes with different libraries inside of it. So the global interpreter lock, I don't know how many of you are familiar with it, but in very succinct terms, it basically means you can only have one thread inside a Python process running at a time, which has a vast impact on low latency model inference times. So this new version uses async IO, which does help mitigate that. I think the last person was from Meta. I think they dedicated a couple engineers' time to try and remove the GIL from Python, so that's cool. V2 can also be used with any mesh. So with V1, we are bound to Istio, which again, not everybody was familiar with, but Istio is its own beast to deal with. So this allows you to use something like Linkerd or something else if you're more comfortable using that. And based on the PAC that we ran, V2 of Seldon, which uses ML Server, sorry, let me correct myself. We were just using ML Server, not so much with V2, is significantly faster than just bare bones Seldon V1's microservice. So the data-centric request flow means that the entire orchestration of your DAG is done via Kafka. Kafka, how many of you know what Kafka is? Okay. Kafka basically has different, you can produce stuff to a topic, they're called, and then you have consumers that pull information from that. So It's a bit different than V1 because V1 had a container that was injected into your pod that orchestrated that DAG for you via actual REST or gRPC calls. So you send a request to the container. Seldon's orchestrator would then take that and say, okay, I need to invoke this container first, then this one, then this one. V2 says you're going to put information into a topic, and then the consumers are going to consume off of that. And what they do with that output is up to them, or the definition of the pipeline or the experiment. And then that kind of flows on through Kafka. Kafka is not provided by Seldon, but it is a hard requirement of the V2 offering. And it requires a decent amount of subject matter expertise to maintain that cluster. A job or two ago, their Kafka topics were always getting messed up, and there were people dedicated just for that. We still have questions about Kafka. Particularly, we have to consider enterprise policies when introducing Kafka, be it managed or managed on our own. And initial testing indicates performance of ML server without V2 orchestration through Kafka is faster, but we need to fully review that whole process, which would mean including like a V2 or a Kafka orchestration. And yeah, so this shows, again, a more graphical version. This pipeline defines two topics, an in and out. So the pipeline gets invoked, it goes to this topic, Model A consumes from it, produces to here, Model B consumes from that, produces to here, and then it ultimately results at the end of the pipeline. You can plug different node types in here, so we can have like some exporter or an explainer at those topics, which is pretty neat, because again, you get to plug like Lego bricks kind of together to build a graph without having to change literally everything like you did with V1 in that custom resource definition. The inference APIs are also a little bit different, or actually significantly different. The V2 uses I think it's the open inference standard, I believe is what it's called, but it treats everything like a tensor, whereas yeah, so like you have to, these are examples of the V2. Just about everything is a tensor in V2, and one of the most common formats used today on our platform is just regular JSON. So like basically a Python dictionary. So converting from a Python dictionary or regular JSON to a tensor, it can be a bit complicated, and that would have a direct impact on user experience. So our POC findings are that Seldon V2 was an alpha, and it was not yet mature enough to support production workloads. The changes necessary were pretty large and have pretty drastic effects on the general process of how do you deploy a model onto MAS. And multi-model serving viability is pretty limited when you have to consider the requirements of the financial industry of how do I prove XYZ happened in this state. The inference protocol doesn't support everything necessary, so specifically calling out JSON data because it is so heavily used. And the graphs are relatively hard to implement from a user experience perspective because you're going from where everything is defined in one file to I have to now define models, servers, and pipelines in many different files, and then make sure that they're all connected together correctly. And Kafka adds just, frankly, a significant amount of complexity that we aren't exactly able to support at this moment. So our recommendations are to improve performance on our existing offering is to fully support gRPC connection between our abstraction API, known as the router, and the model, and then internal communication to the pod, which means from Seldon's orchestrator to the different nodes of the graph, would also be gRPC, because gRPC is just significantly faster, about 15% than regular old REST. We could also consider what I have dubbed Seldon 1.5, which is use certain components from the Seldon V2, such as ML server, in Seldon V1 to reap the benefits of removing the guild contention from within the inference server itself, and enabling it on an opt-in pattern, so that we can step into Seldon V2 easier once it has matured more.
Very good. Thank you, Mike.
Yep.
So I think that kind of illustrates, with one particular example, like all the depth of the technical decisions that go into building these enterprise scale platforms like we do at Capital One. So, this is just one of many decisions that you need to make if you try to build out a large enterprise grade ML platform with all the bells and whistles you need to go from like exploring your data set, training a model, deploying your model, running it in production, and then actually supporting use cases like approve decline decisions and many, many others. So we find ultimately we think this is possible. We do it every day. There's a number of things that go into being successful in that space, right? So systematically doing these POCs, leaning in to exploring new technologies, while being kind of conscientious about like the risks and challenges that you incur as you make these decisions becomes a key aspect. And then in addition to this, you have then a lot of additional tooling that you need to build to really support these capabilities as you release them to a large user base, right? So things like SDKs become a key aspect to this, really making sure that you have a capability that runs, in our case, for instance, across many lines of business with stakeholders that need to be on board with you. So I think that's kind of what we have for you here today. Some other examples here of use cases where MLOps is a key aspect of Capital One. Things like Auto Navigator is a good example, where you use where ML is supporting buying decisions. Our digital applications like Eno for customer engagement. So let me know if you have any questions. I'm especially happy to talk with you about career opportunities at Capital One. I'll be happy to take a couple of questions here. Otherwise, I'll be over at the coffee machine grabbing myself coffee. Thank you very much.